Hello students, welcome to the channel. In today's video, we look at advanced problems from exponential function. So let's begin. Question 1. The graph shown above can be represented by fx is equal to a minus 2 to the power x plus b, where a and b are constants. What is the value of a plus b? Okay, so let's try and work with some points. We know that minus 1 comma 1 is a point on the graph, and so is 0 comma negative 1. And since I need to find a and b, I'll need at least 2 points to find a and b. So let's plug the values. When fx is 1, a minus 2, x is minus 1 plus b. And when fx is minus 1, a minus 2 to the power b. That's just what it is, right? And if I subtract these two, then I get 2 here. The a part gets cancelled and I get 2 to the power b minus 2 to the power b minus 1, right? I write this as 2 to the power b minus 1. So this I can write as 2 to the power b divided by 2, right? Because 2 to the power b minus 1 is simply 2 to the power b divided by 2. And 2 to the power b minus 2 to the power b by 2. If 2 to the power b is x, then this is same as x minus x by 2, which is just x by 2. So this is 2 to the power b by 2. So this is 2, right? So then 2 to the power b is 2 into 2, which is 2 squared. So b has to be 2, right? So that's how we've gotten b. For a, I can just put the value of b as 2 in this equation. So minus 1 is a minus 2 squared, which is a minus 4. So a is 4 minus 1, which is 3. So a is 3. So what is the value of a plus b? 3 plus 2, 5. That's my answer. Okay. Question 2. In the year 2000, when Club Leopard was first introduced on the internet, it had 8,500 leopards or members. In 2007, the leopard population had risen to 22,610. The growth was exponential and modeled by fx is equal to 8,500 times b to the power x, where x is the number of years since 2000. What is the value of b rounded to the nearest 100? So we can see here that when x is 7, because we know the value in 2007. So when x is 7, then f of x is 22,610, right? So then we can write 22,610 is equal to 8,500 times b to the power 7, right? So let's plug this in the calculator. What is 22,610 divided by 8,500? Because if I write 22,610 divided by 8,500, I'll get b to the power 7. So that is 22,600 divided by, 610, right? 1 second. 610 divided by 8,500. So that's 2.66. So b to the power 7 is 2.66. So b will be the 7th root of 2.66, which is to say that it would be 2.66 to the power 1 divided by 7, right? That's what b would be. So that's 1.15. That's 1.15. And we were supposed to give the answer to the nearest 100th, which means that 2 places after the decimal point. So 1.15 is the answer for B. Okay. Question 3. If we take Q amount of a certain medication, the amount of it in our system T hours after intake is 80 Q times 0.8 to the power T. So AT is Q times 0.8 to the power T. This is the amount of medication in the system, T hours after intake. What percentage of the medication is in our system 2 hours after intake? So let's put T as 2. So AT is Q times 0.8 squared, which is Q times 0.64. So we took Q, and 2 hours later, we had Q times 0.64 left in our system. So what percentage of the original? That is 64%. 64% of the original was left in our system 2 hours after intake. Okay. Question 4, the number of cells in a sample at time t measured in hours is nt is equal to 50,000 to the power 50,000 multiplied by 1.6 to the power 0.5 t. Which of the following functions represents the number of cells in the sample after m minutes? Okay, so let's take t as 1. T is 1 hour. So then n of 1 should be 50,000 into 1.6 to the power 0.5, right? This is the amount of cells in the sample after 1 hour, right? And 1 hour is 60 minutes. So P of 60 should also be 50,000 into 1.6 to the power 0.5, because it doesn't matter what unit of time I measure, the number of cells after that much time, whether it's written as 1 hour or 60 minutes, should be the same, right? So which of these values will give me this answer when I put m as 60, right? So if I put m as 60 here, then I don't get that, right? So this can't be the answer. If I put m as 60 here, then I get the exponent as 2, which is not possible. If I put m as 60 here, I get it as 1, which is not possible. And if I put m as 60 here, I get the exponent as 1 by 2 or 0.5, which is exactly what we want. And so the right answer is option D. So this is a very common question on exponential functions on the SAT, where they give you the exponential function in one unit and they ask you to translate it to another unit. So always take some number in the first unit and translate that into the second unit and try and find that, for example, here, if t is 1, then what would you get when m is 60? And those values should be the same, obviously. And then your answer is obvious. Okay, question 5. As part of a laboratory experiment, the number of times the light is flashed on a certain culture of bacteria is reduced 20% each day. If the light is flashed 704 times on the 4th day of the experiment, then the number of times it was flashed on the first day. So the exponential function is given by the formula A is equal to P times growth factor to the power T, where the growth factor is 1 plus R over 100 in case of exponential growth, or it is 1 minus R over 100 in case of exponential decay. So here, the number of times the light is flashed, that number is reduced 20% each day. So we are looking at exponential decay. So my growth factor would be 1 minus 20 by 100, which is 1 minus 0.2, which is 0.8. So my growth factor is 0.8. Now, on the first day, let's say the first day, the number of times it was flashed was P. Then on the 4th day, how many time periods between the first and the 4th day? 3 time periods, right? Second, third, fourth, so 3 time periods. So when T is 3, then A is given as 704. So 704 is P times 0.8 to the power 3, right? And what is 0.8 to the power 3? Let's figure that out. 0.8 to the power 3 is 0.512. So 704 is 0.512 P. So P is 704 divided by 0.512. So that is 704 divided by 0.512. And that's 1375. Right? 1375. So the number of times it was flashed on the first day was 1375, and then it kept declining. Right, so that was an advanced questions drill on exponential functions. If you found this video helpful, hit like and subscribe to the channel. Let me know in the comment section what other videos you'd like me to upload. I'll see you all in a new video soon. Take care. Bye-bye.